Hello guys, welcome to our YouTube channel Deadly Coder. In this video, we will be just explaining the video solution of this staircases, which is the problem E of Educational Codeforces Round 115. Okay, so this is basically a harder problem, and so we will be just first of all going through the question, reading it once, then understanding that what the question actually asks, and then we will see how we can approach it. So let me first read the question. In this problem, we are given some matrix which consists of n rows and m columns. The rows are numbered from top to bottom, and each cell can either be free or blocked. Okay, now we call a path in a matrix a staircase if it starts and ends in free cell, visits only free cells, and it follows one of these two conditions. So either the second cell is one to the right from the first one, the third cell is one to the bottom from the second one, the fourth cell is one to the right from the third one, and so on. So basically it means that either it can follow this structure. As you can see, this is the first cell and this is the second cell, which is one to the right from the first one. Then the third is one to the bottom, this is the third cell which is one to the bottom. The fourth one is to the right of this third cell, and similarly it follows this pattern. Or it might also be possible that it follows this pattern in which this second cell is one to the bottom, then the third cell is one to the right, and it alternates, keep on alternating like this. First go down, then go right, go down, go right. And here what we see, we first go right, then we go down again, right, down, and something like that. And one thing to be noticed here is that a single cell is also can also be called a staircase. So initially we are given that all cells of the matrix are free, none of them are blocked, and we have to process q queries, and each of them flips the state of a single cell. So if a cell is currently free, it makes it locked, and if it is locked, it makes it free. Okay, now we need to print the number of different staircases after each query, and this is just like the general definition to distinguish the ways. And we need to take this nmq and then just print the number of staircases after every query. Okay, so let us first see how we can approach it. So like what we can see is that we can just first of all imagine that what if there were no queries, right? Like suppose we have this, let's say, 3 by 3 matrix. Okay, we have this 3 by 3 matrix, and let's assume that none of the cells are blocked, so which is actually equal to the initial configuration. Like all of these cells are basically free. So if we were to calculate the number of staircases in this matrix, what we can do is that first of all we can just take out all these single cells, because we know that each of these free cells is basically a staircase. Okay, so what I want to say is that total number of staircases is equal to like count of is equal to basically count of free cells plus staircases which have their length greater than or equal to 2, right? So first of all we are using this formula, right? So in order to find the total number of staircases, we first find how many free cells are there, and then we add how many staircases are basically there which has their length greater than or equal to 2. Okay, so counting these free cells is quite easy, and in fact after each query also we can just count these free cells in order of 1. But what is like difficult is counting this one. Like how do we count staircases, number of staircases which has like length greater than or equal to 2? Now first we will be seeing how we can calculate this if all the cells were free. For example, in this case, uh, one of the staircases can be like this, right? And moreover, we divide, actually I categorize my staircases into two types basically, right? I just bifurcate it into two types, right? The first one is horizontal staircases and the another one is vertical staircases. So what do I mean by horizontal? I will call a staircase horizontal if the first two cells are adjacent, like if they follow this kind of pattern, like first horizontal then vertical then then again horizontal, like this. So like this is, I call this a horizontal staircase and this a vertical staircase, right? And for vertical, like first like vertical then horizontal then again vertical, something like this, okay? And so first we will be calculating this horizontal and vertical staircases. And I again remind you that I am calculating the total number of staircases if all the cells were free. So for calculating these horizontal staircases, like as you can see over here, we basically use a dp, right? So let's name our dp as horizontal, right? So let's horizontal of ij. So what will horizontal of ij store is basically the number of, you can say, number of staircases, number of staircases uh, which which ends at I comma j, right? Basically it is the number of horizontal staircases, right? Horizontal of ij is the number of horizontal staircases which ends at ij. Similarly I can also define vertical of Similarly, I can also define vertical of ij in a very similar fashion. But what is interesting is to just note what will be is recursion, right? How we will just relate it. So basically, as you can see here, the horizontal staircases which ends up at this cell is basically 1, right? And similarly, if I want to know what will be the number of staircases which ends up at this cell, this will actually be equal to 2, because one staircase I can take this as this and the another staircase can be equal to like this, right? So this is the second staircase. So so the number of horizontal staircases can actually be written as is equal to 1 plus horizontal horizontal of I minus 1 j minus 1, like and we just basically check the conditions. We just basically check the condition that so that these don't go out of bound, right? So obviously horizontal of ij will be equal to this thing, like 1 plus like 1, because if I want to know what is the number of staircases which ends at this cell, call it, let's say this is my I and j, then this will be equal to 1 plus horizontal of this one, like I minus 1 j minus 1. Similarly, vertical of ij can also be defined in a similar fashion, and there is no issue in that, okay? uh, but actually this is not a true recursive formula, right? Because if I want to know how many staircases which ends up at this cell, this, because it might be possible to have some another configuration, right? uh, Let me just show you some another configuration, right? Let's say if I want to find how many horizontal staircases ends up at this cell, then it might also be possible to have some structure like this structure, okay? This structure is also valid, right? This structure, but in the recursion that we defined below, we are basically just finding the number of staircases which are kind of perfect, right? What I mean by perfect is like something like this, like if I am trying to find how many staircases ends up at this. I am basically taking like this rightmost endpoint, right? But here it is the left part of my uh, bottommost rectangle, you can say. So my horizontal of ij is basically just calculating these numbers of staircases, horizontal staircases, right? So what we need to do is that first we will just calculate all those kind of staircases, and then we need to just add these kind of staircases, right? These kind of staircases. So if I want to know how many staircases are there which ends up at this cell and are of this kind and have this kind of structure. So let's say this cell is ij. So we want to know how many horizontal staircases are there which ends up at this ij and have this structure and not this structure. So this is you can say another horizontal kind of structure. So this the number of staircases having this structure ending at ij will simply be equal to dp, not dp. That will basically be equal to horizontal of I, not I. Basically, it will be equal to I minus 1 and j, right? So this will be the number of horizontal staircases which follow this structure, right? Uh, okay. So again, I would like to just remind you that what I am doing is that for a given matrix, I am calculating horizontal staircases and vertical staircases cases. And for horizontal staircases, I am first having some horizontal of ij which will basically store the count of horizontal staircases which ends up at this and are having this kind of structure, you see, and are having this kind of structure, right? This kind of structure. For example, if I just simply extend this and I want to know how many horizontal staircases ends at this cell, then you see like it will be actually be equal to 3, because either I can take this rectangle, or I can take this pattern, or I can also take this pattern. This will also form staircase, right? So this is basically stored in my horizontal of ij, right? But this is not the only case, right? It might be possible to have thing like that, like I am ending my pattern at this, but I have something like this, you see. This is also one valid pattern, valid staircase. Or it might also be possible to have something like this, right? This thing, I see, this thing, this is also valid, right? So as you can see, I have declared some horizontal 2D matrix and some vertical 2D matrix, taken this nmq nmq, and these activities are basically a number of free cells, basically, right? Number of free cells. Since I know it already that all the free cells are basically staircases, so I am not counting them, right? I will just add them to the answer at the end. Now this is I am doing filling up my horizontal dp table. So if j is greater than 0, which means that something this kind of structure, right? So if it is so, I am just simply saying that okay, so initially all of them are free, so obviously this can be like one staircase for sure. So I am just making it one, and then just taking care of the bounds. I am adding like okay, if this is one horizontal staircases, what can be the other staircases, like adding their count. So how many staircases ends at this cell, which is I minus 1 j minus 1, right? So I am adding that to this. And in a very similar way, you can also just fill your vertical table, right? It is very analogous to the vertical. Now I am having this total. Total is basically storing initially it stores initially it stores the answers, right? It initially store the answer, right? And then what I am doing, like, okay, so as I said you that we are just counting these kind of like horizontal of ij is storing basically these kind of states, right? Like at any particular cell I comma j, how many, like how many horizontal staircases ends up at this point, right? But if we want to know like how many horizontal staircases are there which are basically of this kind, right, which has only one cell, right? Here it was like I am having like this two cells in just one row, and here I am having only one cell, and following this pattern. So this is equal to what? Like if you want to calculate for a particular cell ij, this is basically like count of such horizontal stairs which ends up at this and follow this pattern, right? Only one cell, that is nothing but equal to dp of I minus 1 and then j, right? Not dp, actually it should be horizontal, we are declaring it horizontal of I minus 1 j. And so we need to just add all of them together. So basically what our answer will be, right? So you can say like basically my answer will be something of this kind, right? Let me write it over here. So basically my answer will be equal to number of free cells, right? Free cells, right? How many free cells are there, and plus basically we find the sum of horizontal of ij, right? So horizontal of ij, like for we are just summing them, right? We are just finding that at a particular cell I comma j how many horizontal staircases which are basically of this kind are possible, adding that. Similarly we can just also add sum of vertical of ij, right? And then we will also add that for every cell how many horizontal staircases are possible which follow this pattern, right? For every cell I also need to add that, and I know that it is like the that number will actually be equal to this horizontal of I minus 1 j minus 1. So I will just also add sum of horizontal of I minus 1 then j. And similarly if we just also add vertical I then j minus 1, right? So like this will actually be our answer if we were having no queries, all the cells were free, right? So this would have been the answer, right? So this is basically what I have done. I have this activated is basically the count of the free cells, and then I have just simply added this sum of all the horizontal staircases, summing all the vertical staircases, and then for every cell like this how many patterns ends up at this is basically horizontal of I minus 1 j. So if I is greater than 0, horizontal of I minus 1 j. And similarly the number of basically the number of stairs which are something of this kind, let's say like this. So how does the number of vertical staircases which ends at this cell ij and follow this pattern, right? So I am also adding that, right? So adding that. So till now we before moving to queries we will be having our total number of staircases now. So now we need to just think of that how do we handle the queries, right? So we have our initial answer, we have our answer if all cells were free, right? If all cells were free were free so the question is like how do we handle, right? How do we handle? So how do we handle queries, right? So like this is the major question, like how do we handle the queries? So One important thing to be noticed here is that suppose all the cells, if all the cells were free, right? Let's just imagine a super simple case that if all the cells were free, let's say all of them are having zeros in the beginning, right? Just imagine this very simple case, and once you analyze this, you will just get to know that what we want to know. So suppose if all the cells were free, and let's say we just make this cell as one, right? And we want to know like how our answer changed, like what is our delta factor. Like, so if our initial answer is answer, before moving on to any queries, applying like this query, what will be our next answer, like by how much our answer will change. If we can somehow do this in maybe order of n or m time, then I think we will be just passing this test cases, because you see like the number of queries are 10 to the power 4, and if you just simply multiply it with n or m, it will be 10 to the power 7. So basically we want our answer to be of this order, like order of n into queries or order of m into queries, like it don't matter. So how how can we just evaluate our answer in just order of n or order of m in a single query? So the first thing to be observed here is that the number of staircases, uh, if we are changing the cell x comma y, right? So if the cell x comma y is basically flipped, right? Obviously horizontal of x y, horizontal of x comma y, and vertical of x comma y will change, right? Obviously they will change, right? And we need to handle that case considering several corner cases as well, right? So so let's say we just change this 0 to 1, then obviously uh, the number of horizontal staircases which will end up at this cell will change, right? And similarly the number of staircases which ends up at this cell, right, at this cell will also change, right? And and if this will change, then if it were some more bigger matrix, let's say like this, then changing this cell will actually impact this cell, and which in turn will also impact this cell, because for calculating the staircases at this cell I need to have the staircases at this cell. Okay, because you remember this recursive formula, like horizontal of ij is equal to 1 plus horizontal of I minus 1 j minus 1. So the value at index ij basically depends on the index I minus 1 j minus 1. So changing this value will actually impact this value, the horizontal staircases number of those staircases at this value, and similarly it will just keep on changing, right? So as we can see that we need to update the number of horizontal staircases at this level, at this cell, then this cell, then this cell. So they basically there are order of, you can say like maximum or minimum of n comma l m comma n cells which needs to be updated, right? Similarly, if we just change this cell, then obviously the number of vertical staircases ending at this will change, and the number of vertical staircases ending at this will change. Similarly this will also change, right? So basically in short I want to say you that whenever you change a particular cell, uh, only order of, you can say, n or m, right? Only you, or you can take maximum as well, only order of maximum of n comma m cells will change, right? And so you only need to change the horizontal or vertical values in those cells as only, right? So as you can see, I have taken the queries, right? Taken x and y, decremented x and y just to have them in zero based indexing, and then I just simply subtracted the number of free cells, because I have just subtracted, because like at the end I have added it back, because activated cells can be just maintained very easily. Number of free cells are easier to maintain. We just need to keep checking whether the cell was changed from free to dead or dead to free, right? So depending on that, we just add at the end total plus activated, right? uh, the main thing is uh, changing these values, right? Changing, like updating these values. Like if we change this cell, then I need to update all the horizontal and vertical values, vertical staircases values for all these cells, right? Like ij, then updating I plus 1 j plus 1, then updating I plus 2 j plus 2, right? I need to update all those cells. So like first of all, I just subtracted the activated, like how many free cells. Then I just also subtracted the older values of my horizontal staircases which ends up at this, and then also subtracted the older value of vertical staircases which ends up at this. Then I just checked, like if it was earlier some free cell, then I know that it will actually become now a blocked cell. So okay, so yeah, but one thing is to be noticed here is that not only we just need to update these values, but also we need to update some other values. Let me just see you. uh, okay, so as soon as I changed it to 1, right? uh, Actually the thing is that okay, I changed this value, then I changed like all these values, sorry, this value, then this value if it were some bigger matrix. So I'm changing all those cells, but we need to change something else as well, right? Because uh, because it might be possible that it might be possible that we were having some value like this, right? We are having some value like this. So I just also need to manually just remove this value or add this value depending on whether I am making it 0 or 1. So we also need to keep uh, care of these things, right? Actually it's a bit complicated question, right? And ooh, so we just also need to keep on updating that. So as you can see, I'm first checking if it is a free cell, a of x comma y. If it is a free cell, then I'm checking that if x is greater than 0, then I'm just basically subtracting total minus is equal to horizontal of x minus 1 and y, right? So horizontal of x minus 1 is like, let's say I am basically standing at this cell, right? Let's say this is my x comma y, right? And so if it initially it was 1 0, right? And I am changing it to 1, then I'm checking that if x is greater than 0. Since yes, x is greater than 0, I am just subtracting total minus is equal to horizontal of x minus 1 and y, right? The thing you can just see like why, because you see like if some cell is 0, right? And let's say it was something, we have something like this, right? So uh, we in our initial answer we have added all the staircases which are of this kind, right? Which are of this kind. And since we are changing this 0 to 1, I need to remove all those I need to remove that, right? I'm changing 0 to 1, so now this will no longer be a valid staircase, so I need to remove it anyway. So that's why if my current value is 0 and if x is greater than 0, then I am just removing this value, right? I am just removing the number of horizontal staircases which ends up at this, because otherwise it will just keep on this value. So I need to remove that. So that's why I just first of all removed that. Similar is the case for vertical. So similarly you can just remove this value, and then you can do similarly. So this is the case where we are having some staircase which ends up at this point and have structure like this, right? Structure like this. For horizontal, like for vertical also, you can just have something like this, right? You can have just something like this kind of staircase. So if this value is 0 and you are turning it to 1, you need to subtract the number of vertical staircases which ends up with this, right? So this is what we are doing here, right? We are doing here. The other case is like if x plus 1 is lesser than 1, lesser than n, and a of x plus 1 comma y is equal to 0. You need to basically subtract horizontal of x comma y. So what it means is that if there is a cell x comma y, right, and if x plus 1 is lesser than n and a of x plus 1 comma y is 0, so if this is 0, right, if this is 0, then also I need to remove this x comma y, right? Because you see, like if this is 0, uh then maybe you can see like maybe there is some staircase possible with this, right? Some staircases might be possible which includes basically this cell. So as sorry, so if this is equal to 0, a of x plus 1 comma y, so this is my x comma y and this is x plus 1 comma y. So if it is 0, then it might be possible, so obviously we would have been added this dp of x comma y in our initial answer, so we need to remove it again, right? So that's why I just removed it. Similar is the case for vertical as well. And then for, and we have just updated the values of horizontal of x comma y depending on the values of x and y, right? We have just depending on whether this is 0 or 1, we have checked certain conditions, right? Like you see, if a of x comma y is 1, which is mean it is blocked initially, so after making the query or operation it will be free now. So I check like if y is greater than 0, then uh, if the cell which is just uh, just above it and has this value 0, not just above it, just adjacent to it and to the left of it, right? So like if this is some value, right, if it is 1, right, so after changing it will become 0, right? So I checked this one, right? If this value is 0, right, then obviously after changing this 1 to 0, we will be having at least this one horizontal staircase, right? So that's why if it is so, I am making it 1, and depending on whether there exists some previous row or not, if it exists, then I am just adding how many horizontal staircases exist which ends up at this, right? So I am just adding that to my answer, to horizontal of xy. So basically here we are just updating horizontal of xy, and here we are updating vertical of xy. Since xy is the cell which is changed, so we are just updating the values of horizontal of xy and vertical of xy, right? And then we are just updating that uh, then what we are doing is that we are updating the cells which are adjacent to x comma y and may have x comma y included as their answer to horizontal of that cell or vertical of that cell. So like you see, if x plus 1 is lesser than n and a of x plus 1 comma y is equal to 0, then basically I'm adding total of horizontal of x comma y, right? So let's say if x comma y is this cell, right, if x comma y is this cell, and if a of x plus 1 comma y is equal to 0, right, if the cell which is just below it, right, if this is 0, right, then we are adding the horizontal value of this, Now the reason is why, because you see, if this value is 0, then we can have horizontal staircases like this. So we have updated the value of this, so we are just adding the horizontal of this cell to our answer, right? So that's why we have just updated this total. Similarly for vertical, right? And after updating the horizontal of xy and vertical of xy, we are again adding it, because we have removed it earlier over here, so we need to add them, right? And this is just we are just updating for every cell, right? As I told you that what I have told, that updating, like so as I said, like if you update this cell, then you need to also update this cell, and then you also need to update this cell as well. That's why we are just jumping by one and updating all these cells, making some required conditions, checking some required conditions. I know that this is a bit complex code, right? uh, Actually this is a tougher question for sure. And so this is basically what I am having this delta, from moving this delta from 1 to maximum of n comma n, and then like basically I am jumping from here to here, then here to here. And if at any point this is not a valid coordinate, break. Otherwise some make some required changes. First of all, remove the old values of those cells, right? Remove the old values of those cells, and then update it, right? It's a bit complex. You just try to um, code it by yourself. Think of all the cases, corner cases, right? And so this is basically what I have done, right? And after making these changes, right, you just updated all these values, right? So if you change a particular cell x comma y, right, basically what you are doing, you are just updating every cell which comes like this, right? So you this is x comma y, you updated this cell, then you also changed, modified the value of this cell, modified the value of this cell, basically changed the horizontal values of all those cells. Similarly, like if x comma y is like this, then changing this will actually affect the cells over here. Like it will affect this one, it will also affect this one, and so on and so forth. But there is another way also, another group of cells also which will be affected. For example, if this is the cell x comma y, you changed it, then basically this cell will also get changed. The dp value of this cell will get changed. Why? Because let's say if it was 0 and this was 1, right? If you change this 0 1 to 0, basically it will add one staircase to this, right? So the number of staircases which ends up at this cell will actually get incremented by 1, or not incremented by 1 basically, but still it will be greater than 1. It depends on what is the configuration here as well. But the fact is that if you change the cell x comma y, the value of horizontal and vertical staircases change not only for this x comma y, but it will also change, basically the horizontal dp table values will change for this as well as for this, right? And if it changed for this, basically it will also gonna change this, right? And then it will also gonna change this, right? So changing this will change this one, and changing this will change this one and this one. So this is basically what I am doing. uh, I am just trying to change this x comma y plus 1. This cell is basically x comma y plus 1, so just change that. And after changing that, just simply change these cells, right? Moving one step down and one step right, like this. This is using the same previous way of doing that, delta and doing things. And this is the vertical case, right? So like uh, you see, like if you change the sum cell x comma y, right, this cell might also get changed. This is basically x plus 1 comma y, right? And if this cell gets changed, the vertical value of this cell if get changed, then the vertical value of this cell might also get changed. the vertical value of this cell might also get changed, right? And so on and so on. So this is what I am doing over for the vertical case, x plus 1 and y. First of all, change that value, that cell only. First of all, change, make required changes to this cell, and then you just keep on moving down and right and keep on changing the required values. So this is using like doing that thing, right? And at the end, just flip the value, right? And after flipping the value, we also need to check that if it can be a part of some horizontal cell like this, right? Okay, right. So this is like what if a of xy is 0, right? Let's say if a of xy, okay, so let's say if it is 0. If it is 0, then I check if x is greater than 0. If it is so, then total plus horizontal of x minus 1y. Okay, so let's say x comma y is this cell. Let's say this is x comma y, and if it is equal to 0, I am just adding this value, right? I'm adding this value. Why? Because it might be possible to have some structure like this, right? To have some structure like this. So that's why we just also need to add this one. And similarly for the vertical case, you can add, and depending on whether the cell now is activated, free or dead, you can just simply increment or decrement the activated, add that to total at the end, and then you can just print it, right? So I know that this was a bit complicated, but in short, let me just remind you what we have done. So first of all, we have counted the number of staircases which would be present if all the cells were free. Then for every query, we just noted down that changing the value at one cell, how can it affect its neighboring cells or the other cells. And by observation, you will find that changing the value at some cell x comma y basically affects the number of staircase values in at most order of maximum of n comma n cells, right? So we just only need to update the horizontal and vertical staircases and in those cells, right? And after taking care of all the cases, you can just simply print the answer. But yeah, there are the staircases, you have to just keep on mind that there are basically two types of staircases, right? If you take the horizontal type of staircases, then ending at a particular cell, let's say this, either it can end like this or it may end like this, right? So for counting the number of staircases of this kind, we have used horizontal, and for counting staircases of this kind, we have just added the number of, okay, this is actually vertical one, sorry. For counting the number of staircases which are basically of this kind, we are just basically counting the number of horizontal staircases which ends up at a cell one above that cell, right? We are just adding it for all the cells. uh, the case of vertical staircases is very similar to horizontal. So if you understand the horizontal staircase simulation, you can just also make a similar simulation for vertical as well. And taking all those cases, you will find that it will get accepted, like, as you can see. Yeah, okay, so as you can see, it got accepted, right? Yeah, and like 280 826 milliseconds, right? Yeah, so I will give this code in the description. You can just check out there. If you don't understand, you can just comment below, and feel free to ask any queries. And okay, so that's all for today. Thank you for watching, and please like, share and subscribe our channel if you liked it. Thank you.